I'm going to go over the difference in the RISC architecture and the CISC architecture with the help of this website put together by a Stanford student. So CISC stands for Complex Instruction Set Computer, and it's considered a predecessor to RISC, Reduced Instruction Set Computer. And indeed, RISC architectures are now used across a wide range of platforms, from cellular telephones to tablet computers to supercomputers. ARM architecture is RISC. We're going to talk this semester about MIPS, that's RISC. But here we're going to talk about what's the difference between the two, and this website demonstrates the difference by comparing how each go about multiplying two numbers. So you can see this, the goal of CISC is to complete the task in as few lines of assembly as possible. Okay, and how they do that is to build it into the hardware, complicated instructions. So in CISC, a multiply operation is one line. And it's either, the instructions are either hardwired into the hardware or they're done with microprogramming, which we'll talk about later in the semester. RISC, on the other hand, uses simple instructions, and they can all be executed in one clock cycle. A CISC instruction could take multiple clock cycles. It can take variable clock cycles. Different instructions take different amounts of clock cycles. RISC, you know that every instruction is one clock cycle. That enables pipelining, which we'll also talk about later in the semester. So here, the multiply command is actually 4 separate commands. Okay. So, what are the differences? CISC, hard-coded. RISC, software. So the emphasis on RISC in RISC is compilers, making compilers. Okay. The emphasis in CISC is microprogramming, putting it in the hardware. CISC, complex instructions that are multi-clock. RISC, single clock. Small number of instructions. You know, a drawback to CISC, there's a lot of instructions. Only about 20% of instructions are commonly used. Okay? CISC, the code is small. There's very few lines of code. RISC, it's long. And we're going to go through MIPS this semester and find out how long it can take. So hopefully you've gone over the performance equation. And so you know this, right? We've seen this before. Hopefully you've already looked at that video. And what we want to do is reduce the time per program. Now how CISC does that is to reduce the number of instructions per program. CISC reduces that. RISC, what they do is they try to reduce the cycles per instruction. RISC, CPI equals 1. Okay? Now, so today, Intel x86 is one of the few CISC architecture is still around. And part of the reason of that is because compiler technology has improved and that RISC uses RAM, which is cheaper now, making RISC advantageous. So let's look again. What's the difference between RISC and CISC? RISC, simple instructions, and not very many. CISC, complex, and lots of them. CISC, the clock cycles per instruction is greater than or equal to 1, and they're variable. RISC, clock cycles per instruction equals 1. RISC, the emphasis is on software. Compilers. CISC, the emphasis is on hardware. Microprogramming and hardware. Lots of instructions microprogrammed. RISC, small or large code size. CISC, small code size.